Okay, now we start the third question. A factory makes two types of screws, A and B. Each type of screw A requires the use of two machines, an automatic and a hand operated. It takes 4 minutes on automatic machine and 6 minutes on hand operated machine to manufacture a package of screw A, while it takes 6 minutes on automatic and 3 minutes on hand operated machine to manufacture a package of screw B. Each machine is available for at most 4 hours on any day, and the manufacturer can sell the package of screw A at a profit of ₹7 and screw B at a profit of ₹10. Assume that he can sell all the screws he manufactures. How many package of each type should the factory owner produce in a day in order to maximize his profit, determine the maximum profit? Actually, in this question, how many package of each type should the factory owner produce in a day to maximize his profit? Now we have to find the maximum profit. Suppose the package of screw A, number of packages of screw A, we take X. Suppose the number of package of screw A equal to, suppose you take X, and number of packages of screw B you take Y. Okay, you take as number of packages of screw A is X and number of packages of screw B. Therefore we form X number of packages of screw A and X number of packages, Y number of packages of screw B. Here the package of screw A, we can get a profit. How to profit we get? The manufacturer can sell a package of screw A at a profit of ₹7 and screw B profit. Each package of screw A get a profit ₹7 and each package of screw B get a profit of ₹10, and therefore our main function is maximize Z is equal to one package of screw A get a profit is ₹7. Therefore we find X number of package of screw A. Therefore our main function is maximize Z is equal to 7x plus then 10y, which is the main function. Maximize Z is equal to 7x plus 10y, which is the main objective function. Now we find the constraint. For finding constraint, first of all we form a small table. Okay, here affecting themes are there exists two machine. First is an automatic machine, and second is hand operated machine. There's two machine, an automatic and a hand operated, and their time given to number of package of screw A is X, represent screw A, and screw B, number of packages screw B, take B, Y. Each type of screw machine, and it takes 4 minutes on automatic machine of screw A and 6 minutes on hand operated machine to package a screw A. 6 minutes on hand operated, 4 minutes on automatic and 6 minutes on hand operated. It takes 6 minutes on automatic and 3 minutes on hand operated machine to manufacture package of screw B. On screw B, 6 and 3 minutes on hand operated. Each machine is available for at most 4 hours. Here given 4 hours, this is converted to minute. 4 into 50, that is equal to, we get answer 240 minutes. Maximum available time is 2 minutes for each machine, automatic and hand operated machine. Maximum available time is 240. Maximum available means our connecting inequality is less than or equal to, our maximum time is 240, not above, is at most time is 240 minute. Okay, and therefore we get our constraint is 4 into x, 4x plus 6 into y, 6y is less than or equal to maximum available time is 240. So we connect the inequalities less than or equal to. That implies, which is a common term is 2 dividing by 2, we get answer 2x plus 3y is less than or equal to 120, which is the first inequality, first constraint. Now second is 6 into x, 6x plus 3y is also less than or equal to 240. Here also with dividing throughout by 3 we get answer 2x plus y is also less than or equal to 80. That's equation number 2. Here also x and y are also greater than or equal to 0 because number of screws are always positive, it's not a negative quantity. That is x comma y is also greater than or equal to 0. Now we form the graph of these inequalities. Okay, before forming the graph, first of all we form the table. Our main function is z is equal to 7x plus 10y, and our first inequality is 2x plus 3y is less than or equal to 120. Is equal to, we consider plus 120, 2x plus 3y. Here our table, then first of all we put x is equal to x and y, x is equal to 0, and therefore y is equal to 3y is equal to 120 and y is equal to 120 by 3. Answer is 40. Then put y equal to 0, 2x is equal to 120 and x is equal to 120 by 2, we get answer 60. Now the second equation is 2x plus y is equal to 80. Also we take x and y. Here we take x and y. First of all we put x is equal to 0, y is equal to, we get answer 80. Y equal to 0, x is equal to, we get answer 80 by 2, 40. Now plot the points to a graphical plane. First coordinate is a positive. Here x and y are also positive. 0. Here you take 10, 1 centimeter is equal to 10, 10 unit. So 10, here take 20, 30, 40, 50, 60, 70, 80. Also you take 1 centimeter is 10 unit, that is 10, 20, 30, 40, 50, 60, 70, 80, 90, etc. Okay. First line is 0, 40. Here the 0, 40, and second is 60, 0, 60, 0. By joining these 2 points, we get a line. There is 2 plane, upper plane and lower plane, upper half plane and lower half plane. Now we check, we find the 2x plus 3y less than or equal to 120 part. There exists upper plane and lower plane. Here the origin contains the lower plane. So we substitute the value of origin to the given inequality. Now we substitute x is equal to 0 and y equal to 0 to the inequality 2x plus 3y is less than or equal to 120, and the third inequality is 2x plus y less than or equal to 80, 2x plus y less than or equal to 80. Now we substitute the lower part point origin, it's the given inequality, we get 0 plus 0, 0 less than 120, equal to is already the line. So 0 less than 120, that means 0 lies satisfy the given inequality, and therefore shaded region is on the lower half plane. Now the second line is 0, 80, 0, 80, and second is 40, 0. By joining these 2 points, we get another line. Also is upper and lower half. This portion is also contain upper and lower plane. Here the origin is also in the lower plane. So now we substitute the origin to the given inequality. We get answer 2 into 0 plus 0, that is 0 less than 80. already satisfied, so the shading portion is also on the lower plane. Okay, here the common region, I mean the common feasible solution contained the second quadrant, third quadrant and fourth quadrant also. For sure, already here given x comma y is greater than or equal to 0. That means now we collect the common region which is lies in the first quadrant. Here x comma y is greater than or equal to 0 means in the first quadrant ulla ee common region la shaded region, I mean common aayittulla portions, that means ee region which is the common feasible region. It's the common feasible region. It's a feasible region. Now we have to find the maximum or minimum. Now we here find the maximum value. For finding maximum value, first of all we collect the corner points. Here the first corner point is already known 0 0. Here the corner point is 40 0, and this point is also 0 40. Now we find the this corner point. For finding this corner points, we solve these two equations, that is 2x plus 3y is equal to 120, that's equation number 1, and second is here write 2x plus 3y is equal to 120, equation number 1, and second is 2x plus y is equal to 80, equation number 2. Now here x equations are same, so equation 1 minus equation 2 we get, and 2x minus 2x 0 and 3 minus y is 2y is equal to 120 minus 80 is we get answer 40, and therefore y is equal to 40 divided by 22, answer is 20. Now substitute the values to the equation number 2, and therefore 2x plus 20 is equal to 80, and therefore 2x is equal to 80 minus 20 is 60. That implies x is equal to 60 by 2, answer is 30. 60 by 2, answer is 30. We get x is equal to 30 and y is equal to 20. X equal to 30 and y is equal to 20. Now we form a table for finding the maximum or minimum value. Here take the points, corner points, and here take the main function 7x plus 10y. Here we get corner points are 0 0, 40 0, 0 40 and 30 20. Now we substitute the values to the main function, we get answer 0, 7 into 4 28, 0, and 0 into 40 400 plus 30 20. Now we substitute 30 20, we get answer 410. That is our maximum value, we get answer 410, and therefore therefore our function z is maximum at x is equal to 30 and y is equal to 20, and the maximum value, and therefore the maximum value is equal to 410. Maximum value is equal to 410. This is already a maximum value is 410. It's a maximum profit. That's a maximum value is 410 rupees. So profit and 410 rupees not here. That's all. Okay. Now we discuss similar type. Every question we discuss. Now discuss one more question similar to this type of problem. A cottage industry A cottage industry manufactures pedestal lamps and wooden shades. A cottage industry manufactures pedestal lamp and wooden shade. each requiring the use of grinding bar cutting machine. You make any machine, a grinding machine or a cutting machine, and the sprayer. There exist two functions. So first is grinding machine and second is sprayer. It takes 2 hours on grinding machine and 3 hours on sprayer. To manufacture pedestal lamp. It takes 1 hour on grinding machine and 2 hours on sprayer to manufacture a shade. On any day, the sprayer is available for at most 20 hours and a grinding machine and for at most 12 hours. The profit from the sale of the lamp is rupees 5 and that from the shade is rupees 3. Assume that the manufacturer can sell all the lamps and shade that the produces. How should he schedule his daily production in order to maximize his profit? Similar to the last types of questions. Actually, in our LPP problems, there exist two types of main problems. First is maximum problem and second is minimization problem. Majority of 99% of minimization problems are in the unbound region. Here then nowadays our CBC cut the syllabus and here we avoid the unbound problem. So mainly we concentrate on the maximum profit type questions. Okay. Here the cottage industry manufacture pedestal lamps and wooden shades, each requiring the use of grinding machine. And here the industry form two types of product. First is lamp and wooden shade. You take a number of lamps is X and the number of wooden shade. Number of lamps equal to X and number of wooden shade is equal to Y. Number of lamps equal to X and number of wooden shade is equal to Y. Now the maximum profit. Here one lamp, the profit from the sale of a lamp is rupees 5 and that of a shade is rupees 3, and therefore our main function is maximize Z is equal to 1 lamp profit is 5 and therefore X lamp profit is 5X plus 1 sprayer profit is 3 and therefore one shade profit is rupees 3 and therefore Y wooden shade profit is 3Y. Okay, which is the main function. Maximize Z is equal to 5X plus 3Y. Now we form the constraint. For forming constraints, we form a table. Okay. Number of lamps is X and the number of wooden shade is Y. The affected terms are the industry manufactures pedestal lamps and wooden shade, each requiring the use of cutting machine and a sprayer. Grinding machine or cutting machine. Grinding machine and sprayer. There is two type of machine. First is grinding machine or cutting machine and second is sprayer. There is two types of machine. Here it takes 2 hours on grinding machine and 3 hours on sprayer to manufacture, and when forming a pedestal lamp it takes 2 hours on grinding machine and 3 hours on sprayer. Pedestal lamp form ചെയ്യുമ്പോൾ grinding machine 2 hours select ചെയ്യുന്നു, sprayer 3 hours take. It takes 1 hour on grinding machine and 2 hours on sprayer to manufacture shade. Okay, here it take 1 hour on grinding machine and 2 hour on sprayer to manufacture shade. Shade നമ്മൾ ഇവിടെ ഇവിടെയാണ് നമ്മൾ എന്ത് എടുത്തത്, ലാമ്പ് എടുത്തത്. ഇറ്റ്സ് എ ലാമ്പ് shade. Here take 1 hour on machine and 2 hour on machine. And our maximum on any day, the sprayer is available for at most 20 hours. Sprayer is maximum available time 20 hours, and grinding machine is available for at most 12 hours. At most 12 hours. So any quantity is connected with at most. At most means maximum time is 12. That means our connecting inequality is less than or equal to, is at most. And clearly you already learned in our first year class, and at least is connected with at least is connected greater than or equal to. But നമുക്ക് ഈ വർഷം നമുക്ക് at least base ഉള്ള problems ഒന്നും include ചെയ്തിട്ടില്ല. So we connect with at most is less than or equal to. Now we connect in the inequality, we get 2 into x, 2x plus 1 into y is less than or equal to 12, which is the first constraint. And second is 3 into x plus 2 into y is also less than or equal to 20, which is the second constraint. Now x greater than or equal to 0 and y is also greater than or equal to 0, because so they are non-negative constant, because number of lamps is not a negative quantity, and so number of, this is clearly a number of wooden sheet is also a positive value. So x and y are always greater than or equal to 0. Okay, now we form the graphical solution. Okay, that is our main function is z is equal to 5x plus 3y, and inequalities are 2x plus y less than or equal to 12, then 3x plus 2y less than or equal to 20, x comma y greater than or equal to 0. Now 2x plus y less than or equal to 12, first of all we form a table. Here x and y, first of all we put x is equal to 0, y is equal to, we get answer 12, then put y equal to 0, we get x is equal to 12 by 2, answer is 6. Then second inequality, 3x plus 2y is equal to 20. Here also x and y, first we put x is equal to 0 and 2y equal to 20 and y equal to 20 by 2, answer is 10. Then y equal to 0, 3x is equal to, we get answer 20 divided by 3. 20 by 3 is around, you take a round of value, or approximate value of 20 by 3 is approximately equal to 6 point something. Okay, now we plot that at the time clear. Okay, now we plot the graph. Our maximum value is 12. 20 by 3 approximately is equal to, what is 20 by 3? Is 20 by 3 is 20 divided by 3 equal to 6, 18 to 6.6, around 6.7. Okay, approximately is equal to 6.7. Okay, here the maximum value is 12. Okay, here take a 0. 1 centimeter is equal to 2, that's easy to handle the figure. 2, 4, 6, 8. If you have a lot of space, then we put x is equal to 1, 2, 3, 4, etc. I take it's very risky to plot 12. So I take x 1 unit is 1 centimeter is equal to unit. It is 8, 10, 12, 14. Here also 2, 4, 6, 8, 10, 12, 14, 16. Okay, now plot the point 0, 12, 6, 0. By joining these points, we get a line. It is 2x plus y is equal to 12. Now you find a less than or equal part. There is upper and lower part. Here the origin is the lower, contained lower part. We satisfy the inequality, so our shaded region is on the lower half. Again, second point is 0, 10, 6.7. by join these 2 points. Okay, this line is 3x plus 2y is equal to 20. Here also origin satisfy this inequality. It's a lower half contain origin 0, 0, 0 less than 20 satisfy the inequality, and therefore the shaded region is on this way we shaded the region. There is a common region. This common region is lies on the second, third and fourth quadrant also. Also x greater than 0, y greater than 0 means it's the first quadrant. Common region ആയിട്ട് നമുക്ക് കിട്ടുക ഒരു feasible region ആയിരിക്കും. It's a common feasible region. Okay, so it's the common feasible region. Therefore the corner points are 6, 0, here 0, 0. This point is 0, 10. Now the common point, this corner point is, for finding this corner point, we solve these two inequalities. It is 2x plus y is equal to 12, equation number 1. 3x plus 2y is equal to 20, equation number 2. Now multiplying equation 1 by 2, we get answer 4x plus 2y is equal to 24, equation number 3. Now subtracting equation 3 by equation 2, we get answer 4x minus 3x is x, 24 minus 20 is 4, and therefore x is equal to, we get answer 4. Now substituting equation number 1, we get answer 2 into 4 is 8 plus y is equal to 12, and y is equal to 12 minus 8, you get answer 4. Therefore the corner point x comma y is equal, answer is 4 comma 4. This corner point is 4, 4. Now substituting this value to the given function, you get our maximum profit. Now the point is selected here, point, and our main function is 5x plus 3y. Okay, now we select the corner points. So the points are 0, 0, 6, 0, 4, 4 and 0, 10. Now we substitute the values to the given equation, we get answer 0. Here 6 into 30. Now substitute to 4, 4, we get answer 32. And last is again we get answer 30. And our maximum value is 32, and therefore z is maximum at x equal to 4, y is equal to 4, and the maximum profit is equal to 32 rupees. That's all. Okay. There is some extra questions, that is there are some different types that will be discussed later. That's all today's class. Bye.